Good day, everybody. This is Dr. Farshad. I'm the CEO and the founder of the Blue Aqua International Groups. Today, I would be talking about the aquaculture technology and super intensive culture system to create food security. Before that, I will just explain very little about where am I coming from. So we have a group of a company, different part of the world. We are dealing with the farming and supporting the other farmers around the world for aquaculture, especially in the shrimp industry. So we have a very strong hold in shrimp. That's why I have created a center. We call it Dr. Shrimp Center. So this is more about working on the 5 different species of the shrimp that commonly like very popular in the world. So we are trying to have the hatchery grow out, and also we are doing a lot of research on these 5 species. We also working on a different species of the fish, where basically 2 species are our very main focus is the pompano and also jade perch, and also working on the red claw, crayfish and seaweed. We supply our product that we produce in Singapore to different supermarkets and restaurants. Okay, food security. I think this is very interesting topic. A lot of people talk about it. And what is the definition of the food security? I think food security defined by United Nations as all the people at all time have physical, social, and economical access to sufficient, safe, and nutritious food that meets their food preference and dietary needs for an active and healthy life. This is what United Nations defined the food security. And then what really impact today the food security is, of course, we have a climate change. We have a very big growth in our population in the earth. We have an increasing of the food price. We have a lot of environmental stress, and just recently you can see we have a lot of disease outbreaks such as COVID-19 that can change the whole life and living style of human being. If you look at what are the strategy and policy that we have to look at the improving the market and food trade. We have to look at the land use pattern, water allocation, post-harvest food processing, food prices and safety, building local capacity, and also increasing the productivity. I think that increasing the productivity and local capacity are very important. That's what I'm trying to today to address that. And just simply, if you look at the impact of the COVID, that shows that really now after COVID, many countries, many government researchers trying to find a way how aquaculture really can provide affordable and healthy protein. We have many reports from countries such as US, Singapore, Scotland, Canada, and many others that they are trying to push and increase the productivity and the production in aquaculture, because this will help us to be more self-sufficient and we can have a better and sustainable source of the food. Okay, aquaculture. What is aquaculture? If you look at the picture at the bottom right, you can see aquaculture started many years ago. Even though those days that people never wear clothes and people do farming. And today we have a lot of development in aquaculture. We have AI in aquaculture. So those days that many years ago, 1,000 years ago, that people in Java and different parts of the world, they were just taking a small part of the tidal area and start to grow catch some fish larvae, put it there and just leave it them, and they just harvest them for an easy catch. Okay, today we have giant operation around the world. This is one of the largest shrimp farm in the world. I think is the largest, 30,000 hectare of farming area in Lampung, Indonesia, which is failed. So it means that something goes wrong somewhere. Okay, we look many different type of the farming people trying to do, like cover with a plastic, looking at indoor, outdoor, small pond, big pond. Like for me, I have done, like we will discuss more about like what we have done in the shrimp. So we try to increase the production and biomass. But the bottom line is what? Is that definitely we have to go for intensification. We have to increase our productivity, we have to improve our production system, and we have to go for intensification, because generally the fishery and capture fishery is declining, and aquaculture must replace the demand that exists in the market. There are different methods that people trying nowadays for the farming beside the traditional farming that we can see all around the world, like such as RAS system with a different component. Then you have I call it like smart farming. They use different tools, different methods, or they have much more complicated system with a lot of sophisticated and complicated culture system, which is not very easy to really implement in everywhere. So you really need to have very efficient and a lot of educated people to run that kind of system. Then like for the problem of the temperature, we came up with a very simple idea. So we use like an evaporation system in our greenhouse to really lower the temperature of the farm. Or we can use like something like air dome, which no structure, nothing, is very easy. You can just blow up by the air and it can cover very big area. It's very good for biosecurity, very good for the controlling of the environment. All this activity is for one purpose, to increase the carrying capacity of the farming. So carrying capacity means how we can get more biomass from a certain area, certain space. So carrying capacity always limited by the environmental resistance. So basically environmental resistance, such as, I think the most important one is a DO, the oxygen, or like nitrogenous gas or toxic gas or disease, whatever you want to name it, a push down the production. But we always have a biological potential, a potential to grow bigger and bigger. But of course, we can produce like 2,000 ton fish in 1 hectare, or I don't know, or fish or shrimp. So it means there is a limit. So we basically look at the potential and optimum, potential. So optimum biological potential or optimum carrying capacity is what we are looking for. How we can go there? What do we need to know that? So in my line of work, we came up with an idea, I call it green circulation, from green to clean. So we found a way that how we can, in this part of the world, in a tropical area, which we have many different species, so sometimes they are not too expensive even to sell. So how the farmer really can adopt a technology that it doesn't cost them too much and still yet manage to produce more biomass out of that. So if I look at the culture system, so how I divide the culture system in a very simple way people to understand. I make it like water and land. You have shrimp and fish or any other species you grow. You have feed and you have surrounding environment. That's what we have, nothing more than this. But the dynamic and relationship between each one of these sectors, it causes a lot of complication and difficulty to really create a system that is very successful. So when we look at the culture system design, it can be many things. Whatever hold the water, you consider your culture system design. I give you an example of the RAS system here. Or you can have what type of holding water system you have. You have a circular tank or you have a raceway. This is my farm. So some we use a very tall tanks to hold the water. Some we use a very short and like very standard tank. We have a raceway, very long raceway for our shrimp. So it's a different method, but the purpose is still is to hold the animal within the water. Then your system can have many components. You have a fish tank, mechanical filter, biological filter, degasser, oxygen enrichment, disinfection, so you can choose whatever you want. But in the method that we are working here, some of these things is not really applied for us. Like we don't do disinfection in line in the system, or I don't need to use the degasser. So we will discuss what we are using here. So some other system you see even more sufficient. You have like foam fractionated or protein skimmer. You have a different, you use a ozone. So they are all a system that basically you create a clear water system. So you use a lot of energy to remove the energy from the system. So now, but in my opinion, those additional energy that you are removing from system can fit another species that can help you to clean your system. So in our work, what we did, we have created very green areas. Means I don't remove phytoplankton, zooplankton, bacteria especially from my system. My system is recirculating. We reduce those parameters that we know that they are pushing down our carrying capacity, but we maintain very natural and green environment. Okay, the key is oxygen. So whatever system you are doing, still oxygen is the key factor. You can't compromise on your oxygen. You need to have a sufficient oxygen in your system. Everywhere, doesn't matter. You do indoor, outdoor, hatchery, whatever you are doing, you cannot save on oxygen. But how much oxygen do I need? That's the key factor. A lot of people, they have very fixed number for that, which I think is not very true. Because oxygen requirement, it really goes by the dynamic of your system. If you have a system with a very highly oxidized system, you need a lot of oxygen. If your system, you have low biomass, you need, of course, less. So it's a very, very subjective. And the supplying of the oxygen, like for us, we are using liquid oxygen. Maybe somebody use a different methods. But the point is, you need to have a sufficient oxygen that can dissolve in the water very well to increase the saturation of the oxygen in the water. So which these are very much depend on the salinity, temperature, and a few other factors that really make us to understand how much oxygen I need and how I can mix this oxygen to my system. Second thing is the aeration. Aeration, when you have oxygen, aeration required because you want to move the water. You want to circulate. You want to make the water alive by creating a movement. You can do many things, but we use a blower to really do that for us. We have like certain things like protein skimmer. It's very important, but I don't use protein skimmer in line. I use protein skimmer in a closed loop. So but it's very important. Then you come to like some very high tech like AI and all those things. We have a project with the A-Star in Singapore on the determining the biomass of the culture in a green system. It's not so easy. It's very important, but we are working on that for the past 1 year plus 2 years. But I was just seeing that like now in our day-to-day work, you can see a lot of AI apply in human life. Like this example, people using this, they call it the most human AI for the enterprise. Or we have a underwater robot. We are using 1 or 2 model of this for my tall tanks. But these are becoming more and more popular and important. Measurement of your water quality parameter, inline and online measurement, is very, very important. So we take different parameter to measure. They are very important for us to make a judgment about our system. Okay? But the bottom line, the system that I use is green. I have not only my culture species, which can be shrimp or fish or whatever. We have many other things. We have different microorganisms inside that. We have a lot of bacteria. It's one of the key things we have. We have a phytoplankton. We have zooplankton. So managing this and creating a connection between this water and gas dynamic with a biological, interaction that you can see there is the key factors. And even like for our larvae, we are doing the green system. We can do for fish, we can do for shrimp, it doesn't matter because all of this living in the water. The job is to maintain the good water quality so the animal, they know how they can live there. What we have done, if you want to compare our work so far, we have managed to increase the carrying capacity of the shrimp that we grow from traditionally around 1 to 2 kilo per square meter. We are doing now around 15 to 20 kilo per square meter. And we are doing sometimes we are supplying our animal to different supermarket and restaurants in Singapore, and the quality is extraordinary. It's really good quality animal. So I have a patented system to use for my culture system. We call it Mixotrophic system. We have patented this one in 7 countries. I will explain a little bit more about this one later. And then we have another pending for patent. We call it multi-species super intensive zero waste system. So this also I will explain a little bit more about it. So this ideas turning around the circular economy in aquaculture. So we are trying to use the waste of one species for another species, not to change water, not to create waste, and yet to produce sufficient biomass out of all these things. So mixotrophic system is basically about environmental modulation. So we have factors like pH and ORP, very important. Nitrogen phosphorus ratio for phytoplankton, C/N ratio for autotrophic and heterotrophic bacteria, which sometimes carbon can be organic carbon for heterotroph and inorganic for the autotroph. And we have a lot of bacteria. We manipulate the bacteria by using the probiotic, our own probiotic. And of course, we have a lot of algae. So we have like a balance between energy and nutrient. So what we are doing here, we are doing the nutrient balance. Nutrient balance come very simply, that's why I call it mixotrophic system. Mixotrophic system is a trademark that we have. And it's very simple. It's talking about nitrogen phosphorus for bacteria, for phytoplankton. So we try to maintain certain ratio for that, depends on what type of phytoplankton we require. Like you want a green, it's a 30. You want a brown, it's a 10. You want a brownish green, it's 20. And when it comes to this carbon nitrogen ratio, it's very important because usually we don't have much problem with the nitrogen, but we need to supply sufficient carbon. So we apply a lot of sugar and also alkalinity used for us as a source for the autotroph bacteria. Okay. So in our system, the nitrogen cycle very important. I have categorized here the autotrophic and heterotrophic organism. Maybe some people say, oh, how come shrimp and zooplankton are heterotroph? I don't look at that way. I look at that they are utilizing the organic carbon. So we have these 2 groups, and then when you look at the whole things, the most important cycle we have is the nitrogen cycle. If we manage the nitrogen cycle well, definitely we have a very good system. And that the whole key is here. You know, you must have a good ammonification, you must have a good nitrification, and then assimilation. Because in our system we have a lot of green algae. So the green algae will help you really to reduce your nitrogen and phosphorus from the system. And then we have factors like pH and ORP, which they are very important, extremely important. I'm sure everybody know what is pH, what is ORP, so I'm not going to explain. And also the nutrition in bacteria, that's what I call it mixotropic. That's why we trademark as a mixotropic. So we have this ORP has a very close relationship with nitrification. That's why maintaining the ORP in our system in a high level is extremely important. And of course, it's a phytoplankton management. So this is some of the ratios that you can see here. Okay. pH, it's very important to manage because pH fluctuates through the phytoplankton. So we need to make sure we have a good buffering capacity and we maintain a good number of the phytoplankton. Don't overbloom or underbloom. This is very important because for so many years, many farmers, they try to use calcium, carbonate like lime and dolomite in the system. And I think I started like 10 years ago, I was telling people, don't, it's just wasting money. Because what do you need? Alkalinity has nothing to do with the shrimp. Alkalinity does everything with the nitrification and also with basically the buffering capacity of the system. We need a lot of magnesium and calcium in our system. And then probiotic is extremely important. So I have my own probiotics so we apply in our system because by using this probiotic, we basically create a soup of a bacteria that the fish and shrimp swim inside that. So if I want to look at my mixotrophic system in an indoor or outdoor, we look at this way. So at the early culture, we have a lot of phytoplankton bloom. At the end, we have a lot of bacteria bloom. So this is the very simple explanation. Means we take care of the phytoplankton at the beginning because we really don't need too much of bacteria. Still we do have, but we don't push too much because my baby fish or baby shrimp, they need to eat more than they need to get clean. But when you are moving to the end, because your biomass increasing, your feeding ratio increasing, and you need a lot of bacteria to help you to clean and also to prevent the disease. So I have like 3 stages. I call it phytoplanktonic stage. So this phytoplanktonic stage, we have very good bloom of the algae. So we practice this in the outdoor also for so many years. So we have very good bloom of algae. So you look at the nitrogen phosphorus ratio, pH is extremely important. Then when you are moving to the middle of the culture, which really we practice this very well in our indoor system also. So we try to reduce the phytoplankton, we try to increase the number of the bacteria in the system, and at the end of the day, we are pushing to the really very low phytoplankton and a big number of the CFU for the either heterotroph or autotroph bacteria. And we can even do a different way. Sometimes you just want to have nitrification system, you just use the nitrite spike and cut it down, okay? So generally when we look at our management, the pond management or RAS management, anything you want to talk, we look at the genetic, disease, feeding and environment. These are very important. So genetic, what type of, because like in my system, a few days ago I had a presentation for Aquaculture Engineering Society, and then somebody was asking me, okay, how about NO3? I say NO3 really we don't have much problem, but in my system the biggest problem I have is the problem of my sizing. I have a broken size a lot because I do very high density. It's not easy to get the same genetic all the time. So you have some animal grow very big, some animal grow very small. So this genetic, it's very important for us. Then it's come to disease. We manage disease by using, of course, we have a very, good bacteria in the system that they don't allow pathogenic bacteria like Vibrio and other grow, but we have biosecurity. So we need to have the biosecurity for the viral disease and others. And actually disease is not only about the infectious disease. We have nutritional disease, we have environmental disease, we have genetically, problem with animal that they have, they consider disease. Then you come feeding. Feeding is extremely important for us because such a high density, you can't just feed a normal feed. That's why we have been developing a super intensive feed in my company for the past 2 years to try to really reach to the requirement of this animal in such a high density. And of course, environment is one of the key things because this is what they are living there. Okay. So in a simple layman term, we have very simple pond preparation, either outdoor and indoor. You have phytoplankton bloom, water quality, probiotic, nutrient balance, and pathogen, suppression. Then you look at the, I show you some picture from outdoor. So this is what we have, 97% or 98% of our aquaculture industry. Actually, this is one of the farm we work. So you can see we apply the mixotrophic system in the outdoor also. This is not good. Foam, I like the foam. But when you talk about foam, this is the foam we look. Because foam indicate in outdoor and even indoor that your heterotroph bacteria are working very well. So we have very good, we can practice this in outdoor, but the problem, as I say, is the carrying capacity. Indoor, you have biosecurity, you have a lot of other advantage that basically will help you to, and these things cannot practice in a country like Singapore. We cannot have farm like this. That's what we have developed a farm that it can produce a big amount of the biomass in a very small area of land with a very limited water requirement, with a almost zero exchange and reusing of the water. We can use the same water for years and years. We just top up because we can't afford to get water to our system very often. Even my farm is not nearby the sea. So these are this is like, you can see, this is like a last stage in our outdoor system that we have a lot of bacteria. And we do a lot of research. We work with the AIC, with the Thammasat Poly, uh, many university. So we are very glad to have a support of the Singapore, agencies, especially SFA. They help us a lot, and that's all. I appreciate. Thank you very much. If there is any question, I will be very happy to answer. Thank you and have a good day.